Introduction to multi-stage amplifier. This is the last subunit of module 3, and I guess it is more interesting because it will help you to understand the cascading of a single stage amplifier to a for extending the number of stages in amplifier. Contains introduction, types of multi-stage amplifier, RC couple, transformer couple and direct couple. Construction, working and operation for each of the three above mentioned multi-stage amplifier. So introduction to multi-stage amplifier. Multi-stage amplifier, the output of first stage is coupled to the input of next stage using a coupling device. Coupling device can be a capacitor or a transformer. The process of joining amplifier stage using a coupled device is called as a cascading. So now in this figure you can see this is a coupling device which is connecting the first stage of the amplifier to the second stage of amplifier. So this overall configuration is called as a multi-stage amplifier, and the unit that is connecting the first stage and the second stage is called as a coupling device. Introduction continues. So two stage amplifiers are connected in cascade. Suppose the first stage has an overall voltage gain as AV1. Second stage has an overall voltage gain as AV2. We take the product of the two individual voltage gains of each stage to define the overall voltage gain. So in a statement form it is written as overall voltage gain is equal to AV1 into AV2, which is a product of V2 into V1, where V2 is the gain at the output voltage at the first stage, and V0 is the output voltage at the second stage. So it's a product of V2 into V1, V2 V1 into V0 V2, which is approximately equal to V0 into V2. So the overall voltage gain AV1 of the first stage, AV2 is the overall voltage gain of the second stage. If there are n number of stages, the voltage gain of those stages will be the overall gain of that multi-stage amplifier circuit. Coupling device. The basic purpose of coupling device is to transfer the AC signal from the output of one stage to the input of next stage and block the DC to pass from output of one stage to the input of the next stage, which means to isolate the DC condition. So types of coupling. The meaning of coupling is joining of one amplifier stage with the other stage in cascade using coupling device to form a multi-stage amplifier circuit. So there are four basic methods of coupling. Using these coupling devices such as resistor, capacitor, transformer, etc. Resistance capacitance coupling. This is the most likely used method of coupling, formed using a simple resistor capacitor combination. The capacitor, which allows AC and blocks DC, is the main coupling element used. Let us start with the various types of multi-stage amplifier. So, resistance, capacitance, coupling. The coupling capacitor passes the AC alternating current signal from the output of first stage to the input of its next stage. It blocks the DC components from DC bias voltage to effect the next stage. So let us work on the details of this method. Impedance coupling. The coupling network that uses inductance and capacitance as a coupling element are called as impedance coupling network. In this impedance coupling method, the impedance of the coupling coil depends on the inductance and signal frequency, which is j omega L. This method is a popular and very largely employed. So transformer coupling that uses transformer as a coupling device is called as a transformer coupling. There is no capacitor used in this method of coupling because transformer itself conveys the AC component directly to the second stage. The secondary winding of the transformer provides a base return path, and hence there is no need of a base resistance. This coupling is popular for its efficiency and impedance matching, and hence it is mostly used. So direct coupling in the previous amplifier stage is connected to a next amplifier stage directly. It is called direct coupling. So individual amplifier stage bias conditions are so designed that the stages can be directly connected without DC isolation. So direct coupling method is mostly used in a load connected in series with the output terminal of the active element, for example headphones, loudspeaker, etc. So role of capacitor and amplifier. Suppose if there is an input capacitor, the input capacitor present at the initial stage of the amplifier couples the AC signal to the base of the transistor. This capacitor is, if not present, the signal source will be in parallel to the resistor R2 and bias voltage of transistor will be changed. Hence, Cin allows only the AC signal from source to flow into the input circuit without affecting the biasing condition. So emitter bypass capacitor is connected in parallel to the emitter resistor. It offers a low resistance path to the amplified AC signal. In absence of this capacitor, the voltage developed across RE will be fed back to the input, thereby reducing the output voltage. Thus, in presence of CE, the amplified signal will pass through it. Coupling capacitor CC at the output. The capacitor is a coupling capacitor that connects the two stages and prevents the DC interference between the stages and controls the operating point from shifting. It is also called as an blocking capacitor because it does not allow the DC voltage to pass through it. In absence of this capacitor, RC combines in parallel with the resistance R1 of the biasing network of the next stage and thereby changing the biasing condition of the next stage. So amplifier consideration. For an amplifier circuit, the overall gain of the amplifier is an important consideration. To achieve the maximum voltage gain, various configurations are used. A common collector configuration, its voltage gain is less than unity It is not susceptible for intermediate stages. Common base amplifier, its voltage gain is less than unity, hence not susceptible for cascading. Coming to the common emitter amplifier, its voltage gain is greater than unity. Voltage gain is further increased by cascading. So out of all the three combinations mentioned here, common emitter configuration has an advantage that it has a voltage gain greater than unity, and it further increases by cascading. So this is a positive point for an amplifier. So the characteristics of CE amplifier are such that this configuration is very suitable for cascading in amplifier circuit, and hence most of the circuit use common emitter configuration. Types of multi-stage amplifier. So RC coupled amplifier, we have seen that the resistance and capacitance coupling is in short term as RC coupling. This is mostly used in coupling technique in amplifier. So construction of a two-stage RC coupled amplifier. The two-stage amplifier circuit has two transistors connected in CE configuration, and common power supply VCC is used. The potential divider network R1 and R2 and the resistor RE forms the biasing and stabilizing network. The emitter bypass capacitor CE offers a low resistance path to the signal. The resistor RL is used as a load impedance. The input capacitance Cin present at the initial stage of the amplifier couples AC signal to the base of transistor. The capacitor Cc is a coupling capacitor that connects two stages and prevents the DC interference between the stages and controls the shift of operating point. The figure in the following case will show the circuit diagram of RC coupled amplifier. So here we can see a common power supply voltage. This is a stage 1, stage 2. It is connected through a coupling capacitor Cc, R1, R2, Re. This forms a biasing circuit to the stage 1. Similarly, R1, R2, Re forms a biasing circuit for stage 2. Here the load resistance is very low, that is why we can use this for your speaker arrangement or speaker and mic arrangement. So operation of an RC coupled amplifier: when AC signal is applied to the base of first transistor, it gets amplified and appears at the output of the load, which is then passed through the next coupling capacitor to the next stage. This becomes the input of the next stage, whose amplified output appears across its collector load. Thus the signal is amplified in stage by stage action. The important point that has to be observed over here is that the total gain is less than the gain of the individual stage. This is because the second stage is made to follow the first stage. The effective load resistance of first stage is reduced due to shunting effect of the input resistance of the second stage. Hence in multi-stage amplifier, only the gain of last stage remains unchanged. As we consider two-stage amplifier here, the output phase is same as the input because the phase reversal is done 2 times by the two common emitter configured amplifier circuit. Now frequency response of RC coupled amplifier. Here this is a low frequency response, so roll-off rate will depend on the coupling capacitor CC. Here the high frequency response. So roll-off rate will depend on the coupling capacitor at the output of the amplifier stage. Flat response. This is the required path in which signal gets amplified at an uniform rate. So I'm reading out the point on the slide, how the frequency response of RC coupled is formed. So frequency response curve is the one that indicates a voltage gain and a function of frequency. So frequency response of RC coupled amplifier is given above. So it is understood that frequency roll off or decrease of frequency below 50 Hertz and from the frequency above 20 Hertz, the voltage gain for the range of frequency between 50 Hertz and 20 kilohertz is constant. The impedance offered by capacitance is 1 upon twice pi FCXC. So this is almost equal to 1 upon twice pi Fc. It means that capacitance resistance is inversely proportional to the frequency. For the frequencies below 50 Hertz, capacitive resistance is inversely proportional to the frequency. At low frequency, reactance is quite high. The reactance of input capacitor Cin and the coupling capacitor Cc are so high that only small part of input signal is allowed. The reactance of emitter bypass capacitance Ce is also very high during low frequency. Hence, it cannot shunt the effective resistance, emitter resistance effectively. With all these factors, the gain rolls off at low frequency. Now at high frequency, again considering the same point, we know that capacitive reactance is low at high frequency. So capacitor behaves as a short circuit at high frequency. As a result of this, the loading effect of next stage increase, which reduce the voltage gain. Along with this, the capacitance of the emitter diode decreases. It increases the base current of the transistor, due to which the current gain reduces. So the voltage gain rolls off at higher frequency. At mid frequency, the voltage gain of capacitor is maintained constant. In this range of frequency, if the frequency increase, the reactance of the capacitance Cc decrease, which tends to increase the gain. But the overall capacitive reactance increases the loading effect of next stage, by which there is a reduction in the gain. So advantages of RC coupled amplifier. The frequency response of RC coupled amplifier provides a constant gain over a wide frequency range and mostly used for audio application. The circuit is simplified and of lower cost because it employs only the two components, resistor and capacitor, which are cheaper, and it becomes compact with upgrading technology. Disadvantage: the voltage and power gains are low because of effective load resistance. It becomes noisy with age, and due to poor impedance matching, power transfer will be low. Applications of RC coupled amplifier: they have excellent audio fidelity over a wide range of frequency. So audio fidelity means it allows the signal to transfer at a constant rate over a period of time. So that is termed as fidelity. Widely used as voltage amplifier due to poor impedance matching. RC coupling is rarely used in final stages. Transformer coupled amplifier. How it is better than your RC coupled amplifier? Let us see. From the drawback of the RC coupled amplifier, the effective load resistance gets reduced. This is because of the input impedance of the amplifier is low while its output impedance is high. When they are coupled to make a multi-stage amplifier, high output impedance of one stage comes in parallel with the low input impedance of the next stage. Hence, the effective load resistance is reduced. This problem is overcome by your transformer coupled amplifier. Transformer coupled amplifier, the stages of amplifier are coupled using transformer. So let us see the construction of a transformer coupled amplifier. I'll describe this. The amplifier circuit in which the previous stage is connected to a next stage using a coupling transformer is called as a transformer coupled amplifier. The coupling transformer T1 is used to feed the output of first stage to the input of second stage. The collector load is replaced by a primary winding of the transformer. Secondary winding is connected between the potential divider and the base of the second stage, which provides the input to the second stage. Instead of coupling capacitor like in RC coupled amplifier, a transformer is used for coupling any two stages in the transformer coupled amplifier circuit. So transformer coupled amplifier, here you can see this is a transformer and it is directly connected into the load, directly connected into the collector terminal of the first stage, which is acting as a load of the first stage, and the secondary winding of the coupling transformer is directly connected to the base of the second stage, which is the input of the second stage. Okay. And at the output also, again same transformers are used. They have higher advantage and they try to maintain the impedance of the complete amplifier stable. Try to maintain the impedance so that there is no distortion caused due to the mismatch of the impedance in the amplitude of the output signal, and the overall amplification remains constant. The potential divider R1 and R2 and the emitter resistors RE together form the bypassing and the stabilizing network. The emitter bypass the capacitor CE offers a low resistance path to the signal. The total the resistor RL is used as a load impedance. The input capacitor Cin present at the initial stage of the amplifier couples AC signal to the base of the transistor. The coupling capacitor Cc connects the two stages and prevents a DC interference between the stages and controls the shift of operating point. Operation of the transformer coupled amplifier. So when AC signal is applied to the input of the base of the first transistor, it gets amplified by the transistor and appears at the collector to which the primary of the transformer is connected. So now your role of transformer comes into picture. The transformer used as a coupling device in the circuit has the property of impedance changing, means the low resistance of first stage can be reflected as a high load resistance to the previous stage. Hence the voltage at the primary is transferred according to the turns ratio of the primary winding of the transformer. This transformer coupling provides a very good impedance matching between the two stages of the amplifier. The transformer coupled amplifier is generally used for power amplification. Frequency response of transformer coupled amplifier. The gain of amplifier is constant only for a small range of frequency. The output voltage is equal to the collector current multiplied by the reactance of primary. At low frequency, the reactance of primary begins to fall, resulting in a gain reduction. At high frequency, the capacitance between the turns of the winding act as a bypass condenser to reduce the output voltage and hence the gain. So the amplification of the audio signal will not be proportionate and some distortion will also get introduced. This is called as frequency distortion. So what are the advantages of coupled amplifier? They provide an excellent impedance matching. Gain achieved is higher and there is no power loss in collector and base resistors. Efficient in operation. And drawbacks of the transformer. Though the gain is high, it varies considerably with frequency and hence a poor frequency response. Frequency distortion is very high. A transformer tends to produce a humming noise. Transformers are bulky and costly. So let us try to compare the RC coupled multi-stage amplifier and transformer coupled multi-stage amplifier at this stage. So RC coupled and transformer coupled. Fine. If we are talking about the gain, here it is low, it is quite high, sufficiently high. High. Then if you are talking about the impedance matching, here there is a mismatch. In transformer coupled, there is a matching of impedance. In RC coupled amplifier, frequency response is very good. Fine. Next, applications mostly used for impedance matching purpose, used for power amplification, whereas in case of RC coupled amplifier, it is just a voltage amplifier. So used in application, are this transformer coupled amplifiers are used in applications where maximum power transfer is needed. So your day-to-day application comes in analog communication, wherein a huge amount of audio signal needs to be transferred when you are doing the modulation process. So that time it plays an important role for coupling the antenna with the power amplifier. So direct coupled amplifier, the other types of coupling amplifier is the direct type amplifier, which is especially used to amplify low frequency, such as amplifying photoelectric current or thermocouple current. There is no coupling device used, so coupling of an amplifier stage is done directly and is called as a direct coupled amplifier. So construction, here there is a direct coupling here through a transformer. So transistor in the first stage, which is an NPN transistor, while the transistor in the next stage will be an PNP transistor, and so on. This is because the variation in one transistor tends to cancel the variation in the other. The rise in collector current and the variation in beta of one stage can be cancelled by the decrease in the operation. The input signal, when applied to the base of transistor T1, gets amplified due to transistor action, and the amplified output appears at the collector terminal RC of this transistor. This output is applied to the base of the transistor T2, which further amplifies the signal, and in this way the signal is amplified in a direct coupled amplifier circuit. Advantages of direct coupled amplifier are very few. So circuit arrangement is simple because of minimum uses of resistor. Circuit cost is also low because of absence of expensive coupling devices. Drawback: cannot be used for high frequencies. Operating point is shifted due to the temperature variation. Used for low frequency amplification, low current amplification. Now comparison of all the three multi-stage amplifiers. So take the components: RC coupled, transformer coupled and direct coupled. Frequency response is very good in case of RC coupled amplifier, whereas in transformer coupled amplifier it is poor. Direct coupled amplifier is better than the transformer coupled amplifier. Cost wise, RC coupled amplifier is less. Transformer coupled is expensive because you are using a transformer over here, and direct coupled transformer, direct coupling, it is the least. Space and weight, if you talk about RC coupled multi-stage amplifier are less bulky. Transformer coupled amplifier are very bulky because the transformer is huge, and direct coupling, it is the least. Impedance matching, if you talk about, it is not at all good in RC coupled amplifier because there is a loading of second stage on the first stage. Due to that, the current gets reduced, loading, because of loading. So when current reduces, the operating point varies and it becomes unstable. So there are several factors which are considered because of impedance matching in RC coupled amplifier. Transformer coupled, it is excellent because it provides a good impedance matching, and direct coupled, it is good. Uses: this is used for voltage amplification. Transformer coupled is used for power amplification, and direct coupled are used for extremely low frequency signal analysis, are used for low frequency signals. Over here